Okay, this is going to be lesson 6.7. And 6.7 is Convergent series. And sums to infinity. So this is where we're going to get into, instead of a finite number of elements in a series or sequence, we're going to have an infinite number of elements. The word convergent just indicates that even though we have an infinite number of entries, or elements in a sequence or series, the series will converge on a specific value. Okay, so that's something to kind of keep in mind there. Convergent series can only occur when the common ratio, or the absolute value of the common ratio, is less than 1. Okay, so anything between -1 and +1 is when we can have an infinite series that converges on a value. Okay, so what we want to kind of keep in mind here is this. As the number of elements in the series approaches infinity, r to the n approaches 0. In other words, as n gets bigger, we have a decimal number like 1/2. 1/2 to a very large number is going to get closer and closer to 0. There is another formula, and this is again a formula that's going to be found in the booklet. So we have a formula for the booklet. Okay, and this is where we have an infinite series. And it says this: the sum as we approach infinite elements in the series is equal to the first element over 1 minus r. And this only occurs when r is less than 1. The absolute value of r is less than 1. So that's the only time that we're going to be able to see this. All right, moving on. Here's a couple of examples. So let's look at the first one. Example number 1. 18 plus 6 plus 2 plus ... Okay, so this is an infinite series. It keeps going forever. And what I want to find first, find S sub 10. Well, that just means find the first 10. That goes back to what we did on the previous lesson. So S sub n, we know the formula is the first element times r to the n minus 1 over r minus 1. Okay, r cannot equal 1 is the formula. We plug in what we know. Well, we know the first element is 18. We know that this goes on forever, but it has a common difference, or common ratio, common ratio of 2 divided by 6, which is 1/3. 2 divided by 6, or 1/3. So we know this is geometric because it's going by a common ratio and not a common difference. Okay? 6 divided by 18, if you think of it like that, 6 divided by 18 is also 1/3. So we know that r in this case is 1/3. works out pretty nice for us because r equal to 1/3 is definitely between -1 and +1. We're going to figure out this first one. The first 10 elements is going to be the first one, 1/3 to the 10th power minus 1 over 1/3 minus 1. Put it all in the calculator and you get 26.9995. This is 26.9995 or approximately 27. Okay. So the sum of the first 10 is going to be 27. Therefore, the sum of the first 10 is 27. And it makes sense that we have to round that up because if we look at the numbers in the sequence, they're all going to be whole numbers. Oh, that's not necessarily true. Okay. Find S of 15. So just one more time doing this one. Okay, so now find S sub 15. All right, that's going to be 18 parentheses. 1/3 to the 15th minus 1 or 1/3 minus 1. When I work all this out, I get 27. So therefore, S of 15 is also equal to 27. Now, what do you think would happen if I said the first 30? Or the first 45, or the first 100, or the first 1,000. In all of those cases, it is going to come back to the same answer. So if we wanted to find the sum of infinity, now we can just use the formula. The formula says this. The sum of the first infinity, in other words, if we kept going forever, is equal to the first over 1 minus r. So the sum of the first infinity is going to be 18 over 1 minus 1/3. That's 18 over 2/3. On a calculator, 18 divided by 2/3 is going to be really 18 times the reciprocal, 3/2. And 2 goes into itself once, 2 goes into 18 9 times. 9 times 3 is 27. So when we have a situation where we have a geometric sequence, and in that geometric sequence we have a value of r that's between -1 and +1, no matter how many elements I try to add up, this thing keeps converging on the same value. Okay? All right, let's try another example. So the next example says this: the sum of the first 3 terms in a geometric series is 148. And the sum to infinity is 256. Find the first term and the common ratio. Okay, in this case, you know that r has to be, the absolute value of r has to be less than 1. Okay, we know that because they gave us a sum to infinity and it converges on a specific value. So we know that the absolute value of r has to be less than 1. So there's where we're at that point. So to find either one of these pieces here. So let's do this. We know the sum of the first three terms, which would be u1 times 1 minus r to the n over 1 minus r, has to be 148. We also know that the sum to infinity is going to be u1 over 1 minus r, and that has to be 256. So this is what we know so far. So if I took this second one here, knowing that n is going to be 3, therefore, u1 1 minus r times 1 minus r to the third. That's really just this one again. Is going to equal 256 times 1 minus r to the third. Because what I can do in this equation right here is I can multiply both sides by 1 minus r to the third. As long as I do the same thing to both sides, 1 minus r to the third. This is equal to this right here. Now we know that this side right here, all this piece right here, we know is 148. Because that was really what we had from the beginning. In the second equation, since I multiplied both sides by 1 minus r cubed, I now have this piece, which can be set equal to this piece. And that's where I got this from. So 148 equals 256 times 1 minus r to the third. Now we just got to solve for r. So we're actually finding the common ratio first. I'm going to divide both sides by 256. Okay, and that's going to become 148 over 256 equals 1 minus r to the third. 148 over 256 equals 1 minus r to the third. And I'm going to solve this for r to the third. So basically, I'm going to subtract this from both sides. And at the same time, I'm going to add r to the third both sides, just to get r positive. Eliminate what I can. I've got r to the third equals 256 over 256, there's the 1, minus 148 over 256. R to the third, therefore, is going to equal 108 over 256. And if I take the cube root of both sides, I end up with the following. R is equal to 0.75 on a calculator. So R would be 3/4 or 0.75. Okay, so we found the value of R, but it also asked us to find, so at this point we found what R is. Now we still got to find the first term, so we have to find the formula that allows us to find the first term. Well, sum to infinity is equal to the first term over 1 minus r. Well, this is probably the easiest formula to use because we know certain things. They told us the sum to infinity is 256. We also know that the value of r is 3/4. So, simplifying this, we've got 256 equals first term over 1/4. Multiply both sides by 4. Sorry. Let's see. This will be easier. Let's cross multiply. And the first term is equal to 1/4 of 256. So the first term is 64. And that should do it for this lesson.